Namaste, welcome to Pythagoras Academy. This is Vikram Dachepally. Is it enough if you just know a formula? Is it not important to know when and where and how exactly you have to use that formula? I will give you one such example which will make this point loud and clear. Consider a particle which is projected from a tower of height h, which is equal to 10 meters, with a speed u 20 meters per second upwards. So it goes to certain maximum height and falls back. So it falls to the ground. The question is to find what is the total time taken by the particle to reach ground, or to find the time of flight of the particle. In this case, we have u up and g down. The equation of motion that we have is r bar is equal to u bar t plus half a bar t square. From this equation, because this is a case of acceleration being opposite to displacement, I can get y is equal to ut minus half gt square, because u is up, g is down. I have considered the direction of u and g already in this equation, because u is up, so it is positive, g is down, so I have a negative sign here. Now the value of y when it is hitting the ground, point number one that you should know is that the y is giving you displacement but not distance. Y is displacement but not distance. The displacement of the particle when it hits the ground is 10 minus j cap. It is 10 meters downwards, because in this equation we are taking all downward things as negative and upward things as positive. The value of y should be minus 10, otherwise you'll go wrong. So this is a very, very important step here. If you substitute the value of y to be 10, then you are trying to find the time at which the particle is 10 meters above the point of projection, which is not the time of flight. We need that time of flight, which is the time at which the particle is 10 meters below the point of projection. So minus 10, that is equal to 20t minus half g. G is 10, so g by 2, that is 5t square. So I'll write 5t square minus 20t minus 10, that is equal to 0. So t square minus 4t minus 2, that is equal to 0. T, solving this quadratic, minus b plus b square, 16 minus 4ac, 4 into minus 2 minus 8, minus of minus, that is plus, by 2a. I am ignoring the negative root because time cannot be negative, and it is also saying that there is only one instant of time where the particle is at a displacement of minus 10 units, and it is so obvious. So t is equal to 4 plus under root 24 by 2, that is 4 plus, so 2 root 6 by 2. Finally, I will get the time of flight to be 2 plus root 6 seconds. This is the answer to this question. The important point is y is equal to minus 10. This is the correct way of using or applying a formula for a particular question. Not just this, I'll give you another example. Say there's a balloon which is ascending with a speed u. When it is at a height h, a stone is dropped from the balloon. A stone is simply dropped. There is no initial velocity of the stone with respect to balloon. Now, this particular scenario is pretty much similar to what we have just discussed. A particle projected from a tower of height h. Because velocity of the stone with respect to balloon is 0. That is, velocity of the stone minus velocity of the balloon is 0. So velocity of the stone is equal to velocity of the balloon. So when a stone is dropped from a moving balloon, stone carries the velocity of the balloon. That is the concept of inertia. Suppose you are in a moving train and you cannot just drop yourself from the train, because you will have that velocity of the train, so you might hurt yourself. That is the reason why we have railway stations. If we can simply drop ourselves down, then we don't need railway stations. Whenever we get our station, we can drop down. But it is not the case. We have inertia. If we drop down from a moving train, we will have that velocity. because of this equation. So if a stone is dropped from the balloon, stone is carrying the velocity of the balloon. So velocity of the stone is equal to velocity of the balloon. So if we observe this scenario from the ground, the stone is having initial velocity u up because it is dropped from the moving balloon and from a height h. It is pretty much similar to a particle which is projected with a speed u up from a tower of height h. Even in this case, y is equal to ut minus half gt square. To find the time of flight of the stone, I have to input minus h to y. So ut minus half gt square. Solving this quadratic, we can find the time of flight of the stone. So this is how you clearly and perfectly apply or use a formula. If you have any questions or queries or suggestions, you can always use the comment section to interact with me. I'll be more than happy to respond and receive your feedback. This is Vikram Dachepally signing off. Namaste.